I was going to take a look at implicit differentiation and kind of the assumption, or the assumption for implicit differentiation is that y is a differentiable function of x. So to kind of give you an idea, I'll give you a little example to motivate this. So if we want to take the derivative of y is some differentiable function of x, and one notation for the derivative of y is dy dx. And so if we do an example, say y is equal to 2x plus 5, and I'll take the derivative of that, so dy dx is just going to be the slope, which is going to be just 2. So we have what our dy dx is equal to. Now let's say, for example, I square the y, so then my function is 2x plus 5 quantity squared. Now if I want to take the derivative of this, so if I want to take the derivative of the y squared, I'm going to go ahead and take the derivative of this 2x plus 5 quantity squared, and I'm going to have to use the chain rule. So that's going to bring that 2 down, and it'll be times the base, and then times the derivative of the inside, which is going to be 2. That's what's going to happen here. Okay. So 2 for the outside function with the inside function to the first power times the derivative of the inside function. Kind of multiply that all out. Okay, so there's our derivative, and that's where we have an explicit function. Y equals, we know what it is. Now with implicit differentiation, we can take the derivative of the y squared, and since y is a function of x, we're going to have to use the chain rule. So it's going to work a lot like what we had over here. So when I take the derivative of y, it's kind of a y squared. It's kind of like when I take the derivative of x squared. The derivative of x squared, the 2 comes down. You got x to the first power, and then using the chain rule, we'll have that dy dx. So for example, if you do take the derivative of x squared, it's kind of like it becomes 2 x to the first power, then times the derivative of x, which is just 1, so we do get 2x. So we kind of do use the chain rule there. It's just kind of hidden. Alright, so back to down here, we have 2y times dy dx. Alright, so that's 2, and the y was the 2x plus 5, and the dy dx was 2. And we do in fact get the same thing. So this kind of illustrates why when we take the derivative of y, we get that dy dx, because y is a differentiable function of x. And it so happens that a lot of times it's quite difficult to solve for y, or we may not quite know what y is, but we do know it's a differentiable function of x, which means that the chain rule applies when we take derivatives. So we're going to do, I think, 1 or 2 more examples of this. So let's see what we got here. And in this particular one, I'm going to do it both explicitly and implicitly. So an implicit function is not going to say y equals. So we have, and then an explicit function will have x equals. I mean, not x equals, y equals, sorry. So here we have xy equals 4. This is an implicit function because it doesn't say y equals. Now I have a product of 2 functions. Oops. See if we can put a multiplication dot in there. Got a product of 2 functions, so we got to use product rule. So the derivative of x is 1 times the second function plus the first function x times the derivative of y. And y is a differentiable function of x, so we get the dy dx. Derivative of 4 is 0. Okay? So we're going to subtract y from both sides and then divide by x. So dy dx is equal to minus y over x. Now if we do this explicitly, we would solve for y, and we would have the explicit y equals 4 over x. Then if we take the derivative of this, dy dx, it's kind of like 4x to the minus 1. So that minus 1 is going to come in front. Then we'll subtract 1 from the exponent, so we'll have minus 2. So we'll have an x squared in the denominator. Okay, so 4 over x squared. But wait, these don't quite look the same, do they? Well, we'll have to do a little bit of work to get them to look the same. So y is 4 over x divided by x, and if we simplify that, that becomes negative 4 over x squared. So we do get, in fact, the same thing either way. Okay. All right. Second to last example, we're going to do some implicit differentiation here. So x plus sine xy equals the number 5. So we'll take the derivative. Derivative of x is 1. The derivative of the sine, which is the outside function, is cosine, with the inside preserved, the x plus y, times the derivative of the inside, which is the x plus y. So the derivative of x is 1, the derivative of y is dy dx, and the derivative of the 5 is 0. So what we're going to do here is we're going to subtract 1, because we want to solve for dy dx. So we're going to subtract 1, and then we're going to divide by the cosine of xy. And then the last thing we're going to do is common denominator here is x plus y, so I'm going to subtract cosine xy over cosine xy. That's the same thing as 1. We'll put the negative out in front, and we'll have 1 plus cosine x plus y divided by cosine x plus y. And that's our derivative. Okay. So it would be fairly difficult to get an explicit form for the y here. It might involve some inverse trig, but we'd have some restrictions, and it would be quite messy. So we assume that it's a differentiable function of x and do so implicitly. Okay, one more. I think we did this one in class. Is we're going to do the sine of pi x plus the cosine of pi y. All of that squared, and then equals some constant number. Who cares? All right. So when we take the derivative here, we have an inside function and an outside function. So the outside function, the 2 is going to come down with the inside preserved. Okay, so inside function we write again. And then we subtract 1 from the exponent, so it'll be just the first power. And then we're going to multiply it by the derivative of the inside. So when I take the derivative of the sine, I have to use the chain rule. So the derivative of the sine is the cosine. And then we have pi x. And then we have to use the chain rule on the pi x, and we'll have a pi. So that's where this pi is coming from. Same thing with that cosine pi y. That'll become minus sine pi y. And then chain rule, we'll have dy dt for the y, and we'll also have pi hanging out there too. So all that stuff's hanging out. So that's what's happening here. I didn't show all my work because you guys are all very good with chain rule already. Okay, so cosine pi x minus sine, or I'll put the pi in front from the chain rule, negative pi sine y, pi y dy dt, and that's going to be equal to 0. Okay. Then we're going to divide by this on both sides. And I got 0 on the right-hand side, so this stuff is, we're going to say goodbye to. It's gone. So long. And what we have left is pi cosine pi x minus pi sine pi y dy dx. And that's equal to 0. So we're going to subtract cosine of pi x and then we're going to divide by negative sine pi y. And so I didn't write it in, but when we subtract this, we'd have a negative pi here, and then when we divide, we'd have a negative pi here, and those would drop out, so we wouldn't have to worry about them. Okay? And there you are, implicit differentiation.